Hello everyone, welcome to this lesson. In this lesson we're going to be talking about percentage purity. So how exactly does percentage purity work? Well, as always, I'm just going to do a couple of examples, and by the end you will have a very good understanding of how it works. So pretty much this is the way it goes. And so I've just quickly added the different masses of the elements on the periodic table. So the way it works is the following. First of all, they say here 60 grams of impure. Guys, what does impure mean? It means that it's not pure. It means that that 60 grams is not all of it is NaOH. There might be a little bit of other stuff there. So you cannot use that 60 grams, because if you did, you would probably use the formula N equals to M over M. You would go ahead and you would get the molar mass of NaOH, but then you are assuming that all of that 60 grams is NaOH. Impure means there is other stuff in it. It's not pure. So don't use that. Leave that alone. We'll come back to that later. Here we go. Here's what we're talking about. 22 grams of H2O is produced. Well, that's pure stuff, right? So what we can do is we can go work out the moles of that first. Okay, so we use N equals to M over M. Now that's going to be 22 grams of water. So we're going to say 22 over the molar mass of water, which is H2, which is 2, plus 16, which is going to be a total of 18. And if we go work out the moles of water, we end up with 1.22 moles. There we go. Now what we can do is we can say, okay, well, the mole ratio between water and NaOH is 1 to 1. So I can say NaOH to water is in a 1 to 1 ratio. So if I have 1.22 moles of pure water, how many moles of pure NaOH would I have? 1.22 moles. So now I can use this 1.22 moles of NaOH and see how much mass that actually is by using N equals M over M again. The number of moles is 1.22 equals to the mass over the molar mass of NaOH. So Na is 23, oxygen is 16, and H is 1. So if you go work that out, you're going to realize that the mass of pure NaOH is 48.8 grams. Aha! So here's where the magic happens. So in this impure sample, they gave us a 60 gram piece of impure sample. 48.8 grams. 48.8 grams was NaOH, and the other 10 or so grams, that was other stuff, like junk. So we could work out the percentage purity. So imagine this. Imagine there was an exam out of 60, and you got 48.8. Well, how much percent would you get? That's easy, right? 48.8 over 60 times by 100. I'm not going to worry about fancy formulas. This stuff is so logical if you just think about it. So it's 81.3%. So what that means is that someone walks into your office, let's say you are a person working in a laboratory, they give you a sample of 60 grams, but you don't know how much NaOH there is. So we just worked out that there was 48.8 grams of NaOH, so 48.8 grams out of a total of 60 means that the purity was 81.3%. I hope that makes sense. So here's another one, guys. So look how they start the question. 50 grams of impure. Don't use that one. It's impure. You can't use it, so you ignore that. Reacts with excess hydrogen. 25 grams of NH3 is produced. That's our starting point. 25 grams of NH3. So we convert that into moles. It's all about the moles. And so for NH3, well, we can say the mass is 25 grams. NH3 is going to be nitrogen, which is 14, plus 3 hydrogen, so that's going to be 25 over 17. And if you go work that out, that's going to give us 1.47 moles of NH3. Then what we do is we use our mole ratios, and we mole ratio back to the nitrogen. And so what we can see is that the ratio between nitrogen and NH3 is a 1 to 2 ratio. So if we have 1.47 moles of NH3, then you just divide by 2, and so we divide this by 2, and so that's going to give us 0.735 moles of N2. So 0.735 moles of N2. Then we can work out the mass, and so N is equal to M over capital M, and so the number of moles is 0.735. The mass we don't know. The molar mass is N2, so it's 2 nitrogens, which is 14 plus 14, which is 28. We could then work out the mass, and so the mass of nitrogen is going to be 20.58. So someone walks into your office one day, they give you 50 grams of something, and you've just worked out that in that 50 grams, only 20.58 grams was nitrogen. So the percentage purity, it's not a very pure substance, is going to be how much it is, so how much you got for your exam, divided by the total marks in the exam, and you're going to get a percentage of 41.16%. So that's not a very pure substance. The total mass is 50 grams, but the nitrogen is only 20.58 grams. So Kevin, what is the other stuff? Who knows? It could be sand, it could be, I don't know, insects, who knows what it is, but at least it's not pure nitrogen. So by now you guys should be getting a very good idea of percentage purity. One more question. So here they start us off with 50 grams of impure. Take that away. We don't want to use that. They say here that 25 grams of CaCl2 is produced. So let's start there. N equals to M over M. Number of moles is equal to the mass of CaCl2, which is 25. Calcium chloride, so that's going to be calcium, which is 40, plus 2 chlorines, and each chlorine is 35.5. So that's going to be 35.5 plus another 35.5. If you go ahead, work all that out, you're going to get a value of 0.23 moles of, and that's CaCl2. Then what we do is we just use the mole ratios to go back to the CaCO3. There we go. So we can say here CaCO3 to HCl is going to be a 1:2 ratio. How much not HCl, Kevin. Sorry guys, I mean CaCl2. That is a 1:1 ratio. So what this means is that if we have 0.23 moles of CaCl2, then we also have 0.23 moles of CaCO3. So now we can actually work out, and this number, this is pure CaCO3. So now what we can do is work out the mass of that. So we go N equals to M over capital M. And so 0.23 is equal to the mass over the molar mass of CaCO3. So that's going to be 1 calcium, 1 carbon, whoops, I don't have carbon here, I do apologize, it's 12, plus 3 oxygens, which is going to be 48. If you then go work out the mass by doing the whole cross multiplying and all of that stuff, you end up with 23 grams of CaCO3. So someone walks into your office one day and they hand you a sample of some impure CaCO3, which might have CaCO3, a little bit of jellyfish in it, some insects, maybe there's a piece of an old fridge. I don't know. I'm just making up random stuff now. So they give you a 50-gram sample, but we've just worked out that there was only 23 grams of pure CaCO3. So as a percentage, you would say 23 out of 50, and that's going to give you 46%. So the percentage purity of that sample is not very high. It's only 46%. So that's it, guys. I hope you guys now understand how to calculate percentage purity.